Hi. So in this video I wanted to take a look at 2018 question 1, and I'm in particular interested on the calculation questions, calculations using the volumetric analysis approach. So in this question we're reacting EDTA with calcium carbonate. Calcium carbonate is represented in the reaction with M2+, EDTA with H2Y2-, and concentration of EDTA in this solution, the solution that reacts in this titration, is 0.01 molar, and the volume of the titer is 9.3, and the volume of the sample is 50 cubic centimeters. So I have to calculate a number of things here. The average number of moles of EDTA used in this titration. So I'm using 9.3 cubic centimeters of 0.1 molar EDTA. So I know that there will be 0.01 moles in 1000 cubic centimeters. So I need to find X in 9.3, and for simply X will be equal to 9.3 times 0.01, all that divided by 1000, and that gives me a value of 9.3 times 10 to minus 5 moles. So 9.3 times 10 to minus 5 moles of EDTA reacts with this, are present in 9.3 cubic centimeters of that sample. So then the number of moles of M2 calcium carbonate ions in 50 cubic centimeters of water. To find the answer to this question, I realized that M2 plus to H2Y2 minus react with each other with a ratio of 1 to 1. So if I have 9.3 times 10 to minus 5 moles of EDTA, it means that I have to have 9.3 times 10 to minus 5 calcium carbonate ions. So the number of moles in 50 cubic centimeters is equal to 9.3 times 10 to minus 5. So then I have to find the total hardness of water expressed in grams per liter. Now I need to find to express this in grams per liter, first I need to find the number of grams of calcium carbonate in a liter of water. Now what I know is that in 50 cubic centimeters I have 9.3 times 10 to minus 5 moles. So in 1000 cubic centimeters I'm going to have some number of moles that's as of yet unknown, but I can find that X simply by using my proportion. X will be equal to 9.3 times 10 to minus 5 times 1000, and I need to divide all this by 50. And the value I'm going to get is equal to 1.86 times 10 to minus 3 moles per liter. Moles, I think, no, we here, moles per liter. So I know that I have 1.86 times 10 to minus 3 moles in 1 liter of the solution. That doesn't tell me anything about the grams, but I know that relative molecular mass of CaCO3 is equal to 40 plus 12, 40 from calcium, 12 from carbon, and 3 times 16 from oxygen, and that's 100. And that, if that's the case, that's mass of 1 mole. 1 mole weighs 100 grams. And then I have 1.86 times 10 to minus 3 weighs X grams. So from here I get that X equals to 1.86 times 10 to minus 3 times 100, and that will be equal to 0.186 gram per liter. So to answer this question, the total hardness of water expressed in grams per liter of CaCO3 is 0.186 gram per liter. And then the last question is for me to find answer to the find total water hardness in parts per million. And this is actually very handy to do. All I need to remember for this is the following. that's IV. That 1 part per million is 1 milligram per liter. Or in other words, 0.001 grams per liter. This quantity, the fact that 1 part per million is equal to 1,000th of a gram per liter, makes it very easy for me to find the concentration if part per million, if I have concentration in grams per liter. So I know that my concentration C is equal to 0.186 grams per liter. So from here, it tells me that concentration is equal to 186 parts per million of calcium carbonate in this solution. So again, if I have concentration in grams per liter, by knowing that 1 part per million is 1 milligram per liter or 1,000th of a gram per liter, I can turn that gram per liter concentration into parts per million. So I know that my concentration in grams per liter is 0.186. That's the first thing to know. The second thing I know is that 1 part per million is 1,000th of a gram, 0.001. So then finally I get that concentration is equal to 186 parts per million. Maybe actually, just to make it a little bit clearer, and I know that this isn't something that we might find difficult, I might put it as a proportion. So I know that 1 part per million is 1 milligram per liter, and I know that 1 milligram is 0.001 gram. So I know that X part per million, X grams or X milligrams, is equal to 0.186. So X is equal to 186 milligrams, and that tells me that the concentration is 186 parts per million. So that's it for this video. Thank you for watching. As always, if something is unclear, you can send me a DM or leave a comment, and I'll be more than happy to help. So thanks for watching, and this is Mr. Oziak out.